morning. Today we are going to see on data transformation. In the last class we have seen regarding the data quality. So before doing analysis we need to ensure that all the data should be in the same format and it should be in the same lines. So when the data is not normalized, so it means that either if it is in the skewed form, where the analysis may go wrong. So first of all, we need to bring the data in the normalized form so that the data analytics and the decision making will be correct. So basically, in today's class we are going to see on the data transformations techniques. So it involves scaling, standardization, and reshaping of the features into the forms where the algorithms can learn effectively. So the basics of the transformation is that we need to convert from the original scale or distribution represent a suitable form. So we apply kinds of certain transformation methods by which it is appropriate scaled to bring into a better analytics form. Okay, so we have different transforming techniques. Okay, so when we are using certain kinds of algorithms, we requires the normality of the normality of the data, and the scaling may be required. So when we use the linear or logistic regression, we use either z-score or min-max optimization. So when we are using the support vector missions, we use the standardized score. Similarly, when we use the nearest neighbor methods, so we can use either min-max or standardization, and similarly for other models. So in case of decision tree or gradient boost, it itself has the inbuilt techniques, so we don't require a separate technique to normalize. So what is min-max scaling? So basically min-max scaling is also called as a normalization. It rescales the feature in the fixed range of typically 0 to 1. Okay, so the x dash is equal to x minus x min by x max minus x min. This is the mathematical formula. So when we want to have a generalized range other than the 0 1, so we need to have the starting element a plus in min-max into b minus a. What is the difference between that ratio? We need to multiply. Okay, so the interpretation is that basically when we are using the min-max scaling, so as we have seen that wherever the distance metrics are being used, so it is helpful for us when the norms form. But basically where it affects is that, so when the data is either skewed or when the data is having the outliers, when the mean are used, the mean is basically affected by the outliers. So before doing this, we need to separate the outlier and find the mean, and then apply this min-max scaling. Then the outliers are easily identifiable and removable. And in the case of z-score transform, we have the mean as 0 and the standard deviation of 1. So all the values will be mapped to 0 and 1, and it will be in the normal form. So it is basically z-score tells us that how far the data is away from the mean, population mean. So that's what here from the graph it shows that the center line is the mean, and when the data 55 and 85, we can see that how far it is away from the mean. So basically it will be 1 sigma n minus 1 sigma. Okay, so the score is given, z-score is given as x minus mu by sigma. Okay, so basically the z-score is very easily normalized. Okay, and those values that are away from on the 2.5 on either side, so it will be called as the outliers. So another is the log power transformations. So basically the log and power transformations change the shape of the quality distribution from the data. Unlike the min-max and the scaling, so which only that changes the scale, but the skewed values cannot be changed in the case of min-max or z-score. But when the log transformation can change the skewed data totally into the normal form that we can see in this diagram. So initial data is totally skewed on the left, but when we apply the log transformation, we can see the normality condition is being restored. So basically it is log x to the base e, or we can take as base 10 2. But the problem here is that when you have 0, the log 0 is minus infinity, so we take it as ln of 1 plus x, that satisfies the condition. So log 1 we know as 0. So this small scaling helps us to avoid the undefinedness. So the key takeaways are, so we have to check whether there are RDF features data and what type of distribution it has. If it is heavily skewed or not, we have to see. If has zeros or negative values, then we go for the log transformation. If it is not heavily skewed and need to be bounded between 0 to 1, either we can go with min-max scaling or standardization with the z-score. So these are the summarization. Thank you.